In this video, you are going to learn the best way to construct a septic tank from start to finish. As a civil engineer by profession, this method that I'm about to show you is better because your septic tank will never get full even after 30 to 50 years. I'm going to show you a trick that you can use so that you'll never need pumping. You are also going to learn how to cover your septic tank and lay pavers on top of it. This method is also better because your septic tank will never get clogged. I'm going to break down the whole process into 10 easy steps that literally anyone can understand, with the last 3 steps being the most important ones, so be sure to watch this video till the end because you don't want to miss this. Here is a list of materials required when building a septic tank. 1. Clay bricks. 2. Cement. 3. Sand. Aggregates. Steel bars for reinforcing the walls. Hoop iron. Nails. Timber for shuttering, waterproofing powder, rings, binding wire. You also need materials for the soak pit, so you have to purchase hardcore, a PVC pipe and also a polythene sheeting. The first step is to do excavation, and we decided to make this pit 2.8 meters along the length, 1.7 meters width and depth as 3 meters. Inside the pit, you also have to excavate a bit deeper, say 300 millimeters, to provide a base for the columns at the 4 corners. Be sure to apply termite treatment to the sides and bottom of the pit. The second step is to do steel reinforcement for the columns, and since our septic tank is very small, we are using steel bars of Y12 throughout the entire construction process. For large septic tanks, be sure to use Y16 steel bars and also with a total of 6 columns instead of 4. When cutting steel bars for the columns, be sure that they exceed at least 600 millimeters above the ground because the extra length will act as an overlap into the slab. The third step is to cast a concrete blinding here at the bottom. The concrete mix ratio is 1:2:4, that is 1 part of cement, 2 parts of sand and 4 parts of aggregates. At this stage, we use the same concrete to fill the bases of the septic tank. The fourth step is to build the walls. We set out for the walls and build them around the perimeter of the pit, and in this case, we use clay bricks, the ones of this color, because they have a low water absorption rate. The mortar that we use to build the walls should be of mixed ratio 1:3, that is 1 part of cement and 3 parts of sand. Be sure to reinforce the walls with hoop iron after every 3 courses. This hoop iron runs through the walls and joins to the columns, which makes the walls and columns as a single unit. You have to make sure that the joints are rough and not smooth, as shown on screen, to ensure that the plaster cast later on the wall can stick properly. Also use a water level to check the correct level after every 3 courses. Build the walls up to half height of the pit, and for this case, this was after 10 courses. Step 5 is to do steel bending and steel fixing for the ring beam, and for this mid-ring beam, we are using steel bars of Y12. The height or thickness of the beam is usually 300 millimeters or 1 foot. If the septic tank was very large, we would be having a cross beam in the middle of these walls. Since this particular one is very small, we shall put a beam only on top of these walls. For large septic tanks, for example the ones for hotels, schools or universities which have very many users and are so deep, say 6 meters or more, you have to put several mid-beams to increase the strength of the septic tank wall. For example, let's say the wall is 6 meters. We can decide to put one beam here at 2 meters, put another beam at 4 meters and a slab on top to make the total height here as 6 meters. For our case here, the septic tank is just 3 meters deep, so we simply have to put one mid-ring beam at just halfway at exactly 1.5 meters from the bottom. After doing steel reinforcement for the mid-ring beam, the next step is to do shuttering or formwork for the beam and also formwork for the columns. The next step is to cast concrete of grade 25 to the beams and also cast concrete for the columns at the same time. When casting concrete at this stage, I recommend mixing it from inside if you have enough space. Transport sand, cement and aggregates into the pit and mix it from there. Then cast concrete to its final deposition, that is to the columns and to the beams. This is how the beam will look like after the shuttering. The sixth step is to build masonry walls above the beam. Similar to the wall below, we use clay bricks. The minimum thickness of this wall should be 200 mm, commonly used as header bond. The mortar must be of mixed ratio 1:3, that is 1 part of cement and 3 parts of sand. You must reinforce the walls with hoop iron after every 3 courses. Check the water level also after every 3 courses. Also ensure that the walls are on plumb. Do not create a fair face inside the wall. Make sure that the joints are rough. It helps ensure that the incoming plaster can bond very well with the existing wall. After building the walls, the next step is to do shuttering or formwork for this upper part of the column from the mid-ring beam up to the top of the wall. Cast concrete for the upper part of the columns and then do the shuttering the next day. The walls will be looking like this. The 7th step is to do plastering. When doing plastering, we add 1 sacket of waterproofing powder for each bag of cement. Meaning, let's say you use 5 bags of cement to plaster the sides. You also use 5 sackets of waterproofing powder since we mix 1 bag of cement with 1 sacket of waterproofing powder. This waterproofing powder prevents damp from penetrating through the walls. Begin by plastering the top part for ease, such that when the sand or mortar falls from the top part, you can use it to plaster the lower part below the beam. Ensure that the plaster is on gauge and straight. For our case, we normally use nails and this thread to ensure that we get the right uniform gauge for all the wall surfaces. Do slowering for the top part and then do a wooden float finish on the surface. The 8th step is applying nil on the wall surface. Nil is normally a mixture of cement and water to make a paste which is normally applied on septic tank walls. And the way we mix it is so simple. Simply get 1 bag of cement, mix it with 1 sacket of waterproofing powder, which is usually half a kilogram, and then add water to make a paste to your required workability. You can mix this from a wheelbarrow and then clean it later after work. Put the mixture into a bucket and then apply it on the walls. When applying it, we use a steel float to ensure that we create a smooth surface finish. This extra layer of cement paste prevents damp or liquid sewage that will be inside the septic tank from penetrating into the walls. Do the same for all inner surfaces. We apply the cement paste on the walls on the same day when we do the plastering. Before we proceed, if you're getting any value from this video, kindly hit that subscribe button and the like button. I really appreciate. Let's proceed. Once the cement paste on the walls is dry, we do flooring the next day. We do flooring when all the work in the sides is done. Do screeding on the floor in a sloping way, ensuring that the lower end is at the inlet side and the higher end at the outlet side. This slope helps to keep solids or dense objects in one place at the inlet side, and also to help proper consolidation and settling, ensuring that only liquid sewage exits to the soak pit. The 9th step is to do formwork and steel fixing for the top slab and the beam that supports the slab. Begin by fixing formwork to the inner part of the walls. These vertical posts should be fixed at positions not more than 300 mm apart for the safety of the slab. For all steel reinforcements for this slab, we are going to use steel bars of Y12, that is, steel bars with 12 mm diameter. We only have 1 drop beam in the center here along the shortest side, and then we shall fix another slab beam here running on top along the longer direction. A slab beam is one usually having the same thickness as the slab, and is usually having very many steel bars as compared to other beams. For example, if we are using 4 steel bars in the downstand beam or drop beam, we shall use 6 steel bars in the slab beam. After preparing formwork, begin by doing steel fixing for the beams and then the slab later. Other beams will have 4 steel bars, that is 2 top bars and 2 bottom bars, and then the slab beam will have 6 steel bars, that is 3 top bars and 3 bottom bars. After fixing steel bars for all beams, fix steel bars for the slab. We are keeping the spacing at 150 mm center to center. When fixing steel bars, always remember that steel bars along the shorter side are always the bottom bars, and then steel bars on top are always along the longer side. At this stage, be sure to cut a timber frame to provide space for an inspection chamber or a manhole to to help out to provide access for any future repairs. This frame usually has a square shape of 1/2 meter by 1/2 meter. We make 2 of them, one positioned at the inlet side and another positioned at the outlet side. Also provide a polythene sheeting below. Since we shall not do plastering under the slab, providing this polythene sheeting provides a very smooth surface finish after casting concrete at the underside or soffit of the slab. After this stage, you can now fix the formwork to the sides. Also be sure to bend these column bars that are overlapping and fix them within the slab and the beams. By doing so, you are making the beams, columns and slab as a single unit, strong enough to support the loads applied. The 10th step is casting concrete for the top slab. At this stage, if you have enough money, I recommend hiring a mixer to get high quality concrete. We use mix ratio 1 to 1.5 to 3 for this top slab, that is 1 part of cement, 1.5 sand and 3 parts of aggregates. The concrete used for the slab has to be strong enough since cars will be passing on top of the septic tank. Here is our final product. In case you have any questions about this septic tank, be sure to ask them in the comment section. I will answer all your questions immediately. After building the septic tank, the next step is to excavate a pit for the soakaway, fill it with hard core, install a PVC pipe at the center of the pit because it helps to distribute the liquid sewage evenly to the surrounding. Cover the soak pit with a polythene sheeting and then spread marram on top. The next step is do plumbing, that is the inlet pipe to receive sewage from the main house and also to connect the outlet pipe to take liquid sewage to the soak pit. The way we do plumbing is so easy and anyone can do it by themselves. Sewage from the toilet should be directed towards the inlet pipe of the septic tank, and then wastewater from the washing machine, the sink, bathtub, air conditioning, or any other water with fats and soap should be directed towards the soak pit without passing through the chamber of the septic tank. On top of this, be sure to excavate a very large soak pit so as to soak away liquid sewage seamlessly and easily to the underground. This way, your septic tank will not need pumping even after 30 to 50 years. Then on the other hand, when you direct sewage from the toilet, wastewater from the sink, bathtub, washing machine, air conditioning, all to the septic tank, it will get full very fast, and also fats and oils will disrupt the bacterial action of breaking down the solid sewage into liquid sewage. Hence your septic tank will get clogged and will need pumping all the time, and that's why it's important for the septic tank to only receive sewage from the toilet and not any other wastewater. After building the septic tank and the soak pit, and now you want to lay pavers, cut this pipe on the soak pit to the level of the pavers, cover it on top. Lay a polythene sheeting or any other DPM on top of the septic tank. Spread lake sand and then lay pavers on top. Use road marking paint to mark the positions of the manholes as a reference for any future repairs to the septic tank. In summary, when building a septic tank, the first step is excavate the pit, do steel fixing for the columns, cast concrete blinding at the bottom of the pit and also concrete for the column bases, build the walls, cast concrete for the reinforced mid-ring beam, build the wall on top of the beam, do plastering to the walls, apply cement paste on the wall surface, do steel reinforcement for the top slab and also the beam, cast concrete for the top slab, build the soak pit and then finally do the plumbing. In case you have anything you want to know about septic tanks, be sure to ask me in the comment section. I will reply you immediately. Thank you so much for watching. Click on this video here on the right to know the materials and the total cost for this septic tank that we built.